Okay, so now we want to graph a parabola, and then they want us to identify the focus, directrix, and endpoints of the lattice rectum. Now I'm going to try to make this as easy as possible for you. The first thing I would do is look at the equation and identify, is it a y squared or an x squared? It's y squared. That means it's going to be either this way or this way. Now, I'll give you a little hint. If this number here is positive, then it's going to be opening to the right. This is going to open to the right. So it's going to be this kind, all right? That'll be helpful to us. We know it's in the form y squared equals 4px, okay? So you see how you have the y squared, you have the x, and so that 4p is equal to 24. So I'm going to write 4p equals 24. That's going to allow me to find p, and that's going to be useful to me. Okay. So we know the vertex, they don't even mention the vertex, but we know the vertex is at the origin because of the form that we have here. We'll move them around, you know we will. But for now, the vertex is at the origin, so that's helpful. Now when I graph this, I'm going to put the points that are part of the parabola in black, and then other things I'll put in orange or green. Okay, so we have to find the focus. Well, to do that, we have to know what p is. So we're going to divide by 4 here, and we get p equals 6. Now, you're going to want, for this next exam, you're going to want a really good page of notes, okay, because it's hard to keep everything straight. So you can identify, you can go back to the last video, and what did we say when we had y squared equals 4px? The focus, we'll just review here, was at p comma 0. So now we know where the focus is. For us, it's going to be 6 comma 0 because we just figured out what p was. Okay, so I'm going to count out here 6, and I'm going to draw the focus. The focus is not part of the parabola, but it's nice to have it. Okay, and they told us to put it on. Okay, so there's that. The directrix, and again, you go by that page of notes we just did. It's going to be x equals the opposite of p. So for us, it's going to be x equals negative 6. That means my directrix is back here. You probably can't see that very well with the green, but it's a line. They usually make it dotted, and we're just graphing it. So, and we're saying what it is, x equals negative 6. Yeah, I don't know if I wanted to say anything else about the directrix. It's a vertical line, right? Okay. Now what else do we have to do? The endpoints of the lattice rectum. Okay, so the lattice rectum, I noticed that they've been doing it in orange. The endpoints of, I'll just say LR. If you remember from the page of notes, it's P plus or minus 2P. So for our purposes, it's going to be 6 plus or minus 2 times 6 is 12. Okay? So I'm going to have one endpoint. Now I need to put these in black because they're actually on the parabola. I'm going to have one endpoint kind of up here. My paper only goes to 10, my graph paper. And I'll have one down here. Okay, then here's what we do. Oh, if you want to draw the lattice rectum, the lattice rectum is right here. It's not part of the parabola, but it's that line segment. Okay, now to draw the parabola, to actually graph it, we just do our best. Oh, it got small. It's not going to be perfect, but it's in the right direction, and we just do our best. Okay, that's kind of a big parabola. But there you go. We've graphed the parabola with the directrix and the focus and the lattice rectum, and then here's all the information. You should identify them, which one's the focus and which one's the directrix. And I was just putting the formulas in for you so you could see them. Okay, and I think that's all we had to do, the focus, directrix, and endpoints of the lattice rectum. So there you go.